So we are on rational zeros theorem. It states that zeros of this polynomial, where these are the coefficients, and the coefficients are integers. So it's of the form p over q, where p is a factor of the constant term, that's a subscript 0, and q is a factor of the coefficient of the highest power. So we are saying that this theorem helps us to factor polynomial fast. Yes, by giving us the possible list of zeros, that's factors there, or roots. So we know I apply it if the degree is very large. So you know that's the major problem. If you notice that the degree is too large, so we can't be testing without knowing the boundary. So we use rational zeros. It's part of it. We still use what we call Descartes' rule of sign. So there are all theorems that will help us to factor a polynomial. So let's look at this. We are asked to list the potential zeros. That's the possible zeros of this polynomial. So I'm saying that the rational zero will help us to get the root fast. And I told you that from this theorem that p are the factors of the constant term. So the constant term here is 1. A of 0 is 1. So the factors are plus or minus 1. Yes. Y, q are the factors of the coefficient of the highest power. So q should be factors of 2, which are plus or minus 1, plus or minus 2. So these are the factors of 2. Therefore, the possible zeros here must be in the form of p over q. So the possible roots or zeros must be in form of this over this. So we have, when we divide this by this, we still have plus or minus 1. And when we divide this by this, we still have plus or minus 1 over 2. So for this to have a possible zero, it must be either plus or minus 1 or plus or minus half. Yes. So these are the answer. But let's check whether we are correct. Let's pick 1. If we pick 1 now, f of 1, if we have 0, we know that is one of the zeros of the polynomial function. So let's pick 1 if the remainder is 0. So this is 1. This is 1. This is, so what do you notice? This is 2 minus 1 minus 2 plus 1, which is 0. Yes, have you seen it? So 1 is the root. 1 is the root of the 0, which is here.